Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Boleh dengar semua?
Boleh tak? Dengar.
Okay, nampak tak I share screen ni?
Nampak
Nampak Doktor. Okay, pagi ni saya akan membincangkan tentang what we call the autocorrelation function or ACF and partial autocorrelation function PACF. There is two functions here in time series. One is known as an autocorrelation, the other one is known as a partial autocorrelation function. So these two functions, okay, these two functions in terms of graph. If this function, if we perform, we calculate this function or we perform this function, then we can have a graph known as a, from that we plot a graph. The graph is known as a plotted graph of this PACF and PACF. This plotted graph is known as a colligram. The graph is known as a colligram. So photograph PACF and ACF and PACF is known as a colligram. Okay. Now, before we can plot this graph, this autocorrelation function and partial correlation function, and before we plot this graph, we have to know how to calculate how to find the autocorrelation, or just say that ACF and PACF. Now, ACF, to find the ACF here, you can use the normal, the ordinary correlation. Okay? You can use the correlation function or correlation coefficient. So you can use this correlation coefficient to plot this graph. Okay? And by definition, correlation coefficient is given as if you have two variables x and y. Now, if you have two variables x and y, I have x and y. This, for example, I have x and y. I have x and y, x and y. Okay. So the correlation between x and y, or we put here, normally we put as a row here, is equal to summation of n, summation of x and y, minus by summation of x, summation of y, divide by the square root of n summation of x squared minus by summation of x and summation of squared minus by summation of x squared multiplied by n summation of y squared minus by summation of y squared. Here, okay, this is a formula for correlation between x and y. X and y. Okay. So in other words, this part, this is a covariant. This the top here is a covariant of x and y, and this is a variance of x and y, variance of x, and this is a variance of y. In other words, the correlation between x and y is just a covariance of x and y divided by the square root variance of x and variance of y. These are the basic idea of the correlation. And the term autocorrelation, autocorrelation terms is referred to, this autocorrelation is referred to because of we are using a time series data, a time series. In time series, we refer the correlation as an autocorrelation. Autocorrelation. Okay, that is a autocorrelation. Now, for the partial autocorrelation is just the coefficient. If you have x and y, the variable of x and y. Now, let's say I have two variables here, x and y. X is a independent variable and y is the dependent variable. So the PACF or PAC, partial autocorrelation, PAC, is just what you call the coefficient in the regression line, the linear regression line. So if we can write a linear regression line here, y equal to phi 1, okay, phi 1 y, phi 1 x, okay, phi 1 x, phi 1 x, okay, phi 1 x plus by the error, and this is a partial autocorrelation function. These are partial. This is a PAC, PAC coefficient, partial autocorrelation coefficient. Okay, coefficient. Now, this is for first. If I have two variables here, let's say I have two independent variables. These are for a single independent variable. So if I have two independent variables, let's say I have x, z, and y. Y is a dependent. This is a dependent variable. And here is the first independent variable, independent. And here is also independent variable. Okay? So you have dependent and independent variable. So my multiple regressions, y is equal to phi 1 x plus by phi 2 x plus by phi 2 y and phi 2 z. So 5 phi 1 x, phi 2 z, okay, phi 2 z, phi 2 z plus by epsilon here. Now this is known as the partial. So the partial PAC for this function is this one. You can refer to phi 2. Now if I have three variables, so let's say I have x1, x2, x3, and y. Let's say for example I have like this. My multiple regression can be written as y is equal to phi 1 x1 plus by phi 2 x2 plus by phi 3 x3 plus by x1. So this phi 3 is a coefficient for the third level. So this is a coefficient for PAC. This is a coefficient for PAC. So this is a basic idea of what you call the PAC and ACF. Okay.
Assalamualaikum.
Salam.
Doktor macam mana nak tahu kata PC?
PC.
Macam kalau tiga variable yang tambah ketiga tu PAC.
Ya. Macam mana nak tahu PACF dengan ACF?
Ya doktor, macam tadi tu doktor bagi contoh macam X1, X2, lepas tu yang X3 tapi macam untuk X Z tu maksudnya yang last tu macam mana?
Okay, gini. Now, in time series, okay, in time series, we're talking about time series, okay? We're talking about time series. We have a in time series. Contohnya, katakan kita ada dua data time series. In time series we can use variable x or sometimes I use y. Okay. In time series I can use x or y. In time series, the basic idea of time series, we have only one data. Correct or not? We have only one series of data. The other one is the time. It's a time, and this is a data. Data here can be written as x variable, or you can use y, or you can use z, whatever name you want to use. Okay, whatever name. This is what I call in time series. This is known as the dependent. And time here is referred to independent. Correct or not? So these are dependent and independent. Kalau kita bandingkan dengan normal regression, ordinary regression, you have x and y, isn't it? This is a independent, and this is a dependent. Tapi time series, our independent variable is time, and dependent variable is our x, y, whatever lah. Then in regression, in a normal regression, in regression form, you have dependent y, x is independent. Saya ambil contoh lah, katakan dependent, katakan harga, price depend pada, the price of ice cream depend pada the weather, suhu katakan, the temperature, depend on daily temperature, daily temperature. Kalau suhu tinggi, hari panas, suhunya tinggi, the sales, bukan demand, bukan the price, the sale, this is the sale. So put here the sale. Sales of ice cream in term of money lah, in term of total sales, depend on daily temperature. Kalau harga harinya panas, contohnya harinya panas, depend, harga sale-nya akan meningkat. Itu logik dia. So this is a regression. So that's why we put y depend on x. So of course, if you calculate the coefficient here, you have 5 plus by 5(1) plus by epsilon, because of we have only one variable. Okay. Tetapi time series dia tak begitu. This variable depend on time. Depend pada masa dia, So kalau kita nak buat, kita katakan, so I have here y is equal to 5t plus by epsilon. 5t plus by epsilon. Jadi kalau kita nak berdasarkan kepada fakta ni, so y is equal to 5t plus by epsilon. Tetapi kita tak gunakan ordinary ini. We do not use the ordinary. We have several model. For example, we have AR model, and we have MA model, ARMA model, kemudian we have SARIMA. So the famous one is these are two we in our syllabus we learn about AR model, MA model dengan ARMA model. So AR model, walaupun kita ada time here as an independent, tetapi AR model dia tak gunakan time sebagai independent. Dia menggunakan data previous dia sebagai independent. This AR model, he use a previous data as an independent. So let's say I have data here, I can put Y or whatever. So for this case, let's say I say my data is Y, let's say. The dependent variable is Y. And independent variable is also Y because of we use AR model. AR model say that YT is depend on YT minus 1. YT dia punya dependent bergantung kepada independennya YT minus 1. Dia bergantung kepada masa yang lepas. Dan kalau kita estimate, we have 5-1 here and epsilon here. Okay. This is an AR1 model. AR1 model. Okay. Kalau AR2 model, YT depend pada dua leg yang sebelumnya. So we have 5-1, YT minus 1 plus by 5-2, YT minus 2 plus by epsilon T. So dia depend pada this dependent variable, dia depend pada independent variable dia dalam bentuk data sebelumnya. This is independent variable 1 and here is independent variable 2, data sebelumnya. Okay. This is a time series. Berbeza dengan regression dia gunakan you should have a Y dependent and independent variable. So sales and daily temperature. Kalau katakan kita nakkan gunakan ini sebagai time series, kita kata sales ini this is time. Ikut hari time. Tapi we do not actually use this data sebagai dia punya independent variable. Tetapi kalau AR model kita gunakan sales ni against sales, kita gunakan Y ni against Y, YT against Y, YT against Y ataupun Y sebelumnya. Y hari ini berdasarkan Y semalam. Y hari ini berdasarkan pada Y 2 hari yang sudah. Ini konsep time series. Faham tak apa saya cakap? Boleh respon? Faham? Ha? Faham ke tak faham?
Faham.
Okay.
Doktor, ada orang nak masuk lagi kelas.
Awak ni masuk tak hegi lambat sangat ni pasal apa? Dah pukul 9.30 dah pun nak masuk. Okay. Now, so saya dah bincang lebih kurang dalam 20 minit tentang auto question, basic concept lah. Jadi kalau tak faham kena tanya kawan-kawan lah. Jangan awak tak faham nanti awak menyalahkan saya dah terangkan dia. Nak terangkan ni bukan senang Jadi saya kena pakar yang terangkan. Kalau orang biasa dia tahu nak terangkan benda ni. So I have discussed on this autocorrection function and partial autocorrection function adanya konsep ni. So yang masuk lambat ni sila tanya kawan-kawan lah. Sebab kalau awak tak faham konsep asas ni, you akan lost nanti. You akan tak faham terus. Tapi tak apalah, video ni saya akan upload lah. Tapi bukan hari ni lah. Pasal proses nak upload ni ambil masa lama. Kadang-kadang nak masuk YouTube pun lebih kurang 2 jam, 3 jam lah baru habis lah. Itu duration of 1 hour. So basically, so in this morning, we want to discuss the autocorrection function and partial autocorrection function. And then, so kita akan fokus pada dua model ni, AR model dengan MA model. Then, of course, we can use the ARMA model lah. So a combination of AR and MA is a ARMA. Okay, now let's say I give you a notation. So my data here is I give a notation of Y. Data is Y, time series data is Y. Tak kisahlah data apa. So before this, I give you the data on the stock market. Let's say Y here is a data on stock market. Y is data on stock market. Y is a price of Twitter contohnya. Stock market of Twitter. Tahu Twitter kan? Dia punya harga sahamnya ada Twitter. So inilah harga Twitter contohnya. So kalau if you want to model this Twitter, if I want to use AR model, let's say I define data of Twitter is Y. You can define data as an X also you can define. So kalau you want to calculate AR1 model, this basically is a YT equal to 5,1. Namanya selalunya kita bubuhkan dia punya what we call the constant. Let's say constant is a 5 naught plus by constant can be you can put constant or you can delete the constant here. This doesn't matter. This is not very important. 5,1 y t minus 1 plus by epsilon t. This is a basic model. Okay. Kalau ingat lagi, kalau regression ni jadi apa dia? Kalau regression biasa, y sama dengan a plus by bx plus by epsilon error. Kan? So b ni instead of b here kita change to pi 1, a is a pi 0, x ni is a independent variable. For this case, for AR model, the independent variable ya yt minus 1. Data sebelum dia. Data hari ini kita bandingkan dengan data semalam. That is a AR1 model. Now for AR2 model, AR2 is equal to jom AR2. Macam ni tulis AR2. So AR2 sama dengan y sub t equal to 5 naught plus by pi 1 yt minus 1 plus by 5 2 yt minus 2 plus by epsilon. Ini is yt. Kita dah ada. Maknanya kita bandingkan data sekarang dengan data sehari sebelumnya, data semalam dengan 2 hari sebelumnya. That is AR2. This is happen to AR3. This is the same as AR3. Kita bandingkan untuk 3 hari. So, yt, y sub t equal to 5 naught plus by 5 1 yt minus 1 plus by 5 2 yt minus 2 plus by 5 3 yt minus 3 plus by epsilon t and so on. So if we have ARN for example, so we are comparing today. So yt we are regress against 5. So we have 5 0 against 5t minus 1 plus against 5t minus 2. Previous data, the 2 days. Then the third day, 5 yt minus 3 plus by until the end day, 5n yt minus by n plus by epsilon t. These are how you write ARN model, AR1, AR2. Kita tak dah sampai ARN, we just put AR1, AR2, AR3. The most is AR3. This is how we calculate it. Now, the correlation here, kalau kita nak tengok autocorrelation, it just autocorrelation is basically just a correlation between the variable here and the variables of two variables. To seem to what you call the same to time series data. So autocorrelation, AC autocorrelation is just a correlation. It's just a correlation. Now, if I have y data here, y data, yt, so autocorrelation. So first leg. So in autocorrelation we have we have a term called lag. Lag. L-A-G. Okey, sambung balik dengar eh. So, hello, dengar ke? Hello, dengar ke?
Baru dengar doktor.
Okey, tadi terputus, saya minta maaf ya, terputus tadi. Bukan line saya punya apa dia? Screen saya punya bateri dah habis. Saya lupa nak charge, jadi dia terus terputus lah. So I share the thing here. Boleh nampak sharing saya?
Nampak doktor?
Okay, nampak eh? So the autocorrection, the concept of autocorrection, we use the concept of lag here. So we have to know the lag here, lag. Now let's say I compare YT and I compare with this my dependent. I compare with, I regress with independent. I regress with the YT minus 1. This is known as a lag 1. Kalau I regress YT dengan YT minus 2, this is known as a lag 2. If I regress YT, my independent is a YT minus 3, this is a lag 3, and so on and so forth. Kalau I regress YT and YT minus n, this is a lag n. So basically, the autocorrelation is just a correlation between. Autocorrelation is just a correlation between YT and YT minus 1, YT and YT minus 2, YT and YT minus 3, and so on and so forth, YT up to YT minus n. These are what I call the correlation between these two variables. These are dependent and independent variable, is known as a autocorrelation function. So if we have a series here, we have a series of data. Here is known as a autocorrelation function. Okay. Now, if you have a single here, only one is a autocorrelation. If you have series here, it's known as a we have developed a function here. Here is lag 1, here is lag 2, here is lag 1, lag 2, lag 3, up to lag n. Okay, this is what I call the autocorrelation function. Okay, then we proceed to partial autocorrelation function. Now, for the partial autocorrelation function, I just say that just now is a coefficient between dependent and independent variable. We have the same concept here. Let's say you have the y data here, or I change to x. X instead of y, I change to x. X is also a data. It's a, for that case just now it's a sales. Sales of ice cream. X is also data. You can use x. So let's say I change to x, or never mind. I stick with y. So I afraid that you will be confused on this term. So I stick with y. Okay. Now let's say my data is y here. The partial autocorrelation PACF is just a coefficient between. Now, if I write the first model here, AR1 model. So if I have AR1 model, the first model here is a YT equal to Y 5 naught plus by 5 1 YT minus 1 plus by epsilon T. Then AR2 is equal to YT equal to 5 naught plus by 5 1 YT minus 1 plus by 5 2 YT minus 2 plus by epsilon T. Then AR3 is equal to YT equal to 5 naught plus by 5 1 YT minus 1 plus by 5 2 YT minus 2 plus by 5 3 YT minus 3 plus by epsilon T. And then you have ARN, for example, ARP, or we can use ARP or ARN. ARP is equal to YT equal to 5 naught plus by 5 1 YT minus 1 plus by 5 2 YT minus 2 plus by 5 3 YT minus 3 plus by dot plus by 5p YT minus p plus by epsilon T. These are up to ARP. Now, your PA or partial autocorrelation, partial means we take a part, we do not consider two here. So AR1 here, actually we have only a single variable here. These are AR1. So here depend on leg. Okay? For the leg one, first leg, for the leg one, this is your partial autocorrelation. These are partial autocorrelation. 5-1. For leg 2, we have two variables here. We have 5-1 and 5-2. Because of this partial, we just take 5-2 as your coefficient. And for leg 3, even though we have 5-1, 5-2, 5-3, because of this partial means we take only a part here, only a certain part. So we take only 5-3 as our coefficient. And then for ARP, we just take 5p as your coefficient. So in other words, for the PACF, so PACF, depending on for the PACF, okay, for PACF, in other words, for PACF, depending on leg here, for leg 1, your partial autocorrelation here is a 5-1. For leg 2 is 5-2, and for leg 3 is a 5-3 coefficient, and up to leg P is a 5P. Okay. Then this is a different between autocorrelation function. ACF for leg 1 is a correlation between R1 and 1. Then for leg 2 is R1, Y1 and Y2. Here is for leg 3 is between Y1 and Y3, and then for leg P is between Y1 and YP. Okay. In other words, correlation between YT and YT minus P. This is a correlation between YT and YT minus 3. This is a correlation between YT and YT minus 2. And here is correlation between YT and YT minus 1. Okay. This is how we compare autocorrelation and PACF. PACF is just a coefficient of the regression line. This is a linear regression. This is a multiple regression. Faham? Faham tak faham? Hello? Hello?
Faham, doktor.
Faham
Doktor.
Ya. Sila, tanya sila. Ada apa pula tanya?
Tak ada.
Okay. So, I proceed So, saya proceed. Okay. Kepada so, sini ada nota ni semua okay. Nah, apa gunanya PACF dengan ACF ni? So, ini kalau awak baca nota ni dia akan terangkan benda yang sama lah. Saya dah terangkan tadi lebih kurang dalam masa 30 minit saya dah discuss tentang apa dia autocorrelation and correlation function. I have discuss here. So, you boleh baca nota ni. Okay, now macam mana kita nak tentukan, so apa kegunaan dia ER dengan ACF dengan PACF plot ni ataupun correlogram. Apa kegunaan dia? Kegunaan dia adalah untuk apakah, so ini nak identify dia, so we have identified. Apa kegunaan dia? Kegunaan dia lah untuk the use is to determine what types of model to be used. Okay? So kita basically kita ada ER model kan, kita ada ER model and MA model. So MA model in term of error. So YT equal to katakan letak 5 not plus by, nanti awak ingat sama pula so tukar so kita ada ER model. ER model is written as ER model. Katakan ER1 lah. ER1 is YT equal to 5 not 5 1 YT minus 1 plus by epsilon T. So kalau MA1, MA model, it depend on the error. YT equal to, I change the symbol here, let's say I change to pi 5, katakan. I change to pi not plus by pi 1, so error E T minus 1 plus by ET. This is MA1. Kalau MA2 sama juga. MA2, so YT equal to 5 not plus by pi 1 epsilon T minus 1 plus by pi 2 epsilon T minus 2 plus by ET. These are MA2 and so on so forth lah. So kalau ada MAN, MAP for example, atau MAQ up to Q, YT equal to pi naught plus by pi sub 1 epsilon T minus 1 plus by pi sub 2 epsilon T minus 2 plus by dot plus by pi Q, pi sub Q, ET minus Q plus by epsilon T. This is how we write the MA model and ER model. Okay. Now, macam mana kita nak pilih, nak tentukan dia itu adalah ER ataupun MA model. Itu gunanya kita buat ACF and PACF plots. Okay. ACF and PACF plot. Okay. Now, basically, so kalau kita plotkan ACF and PACF, kita akan dapat gini bila kita plotkan, let's say kita plot. Now, let's say I have this one times again lag, the plot is lag again the coefficient. Coefficient here, these are coefficient. Let's say here is a ACF, AC, autocorrelation function, AC, autocorrelation here, correlation, and here is lag here, lag, lag. So lag 1, lag 2, lag 3, sampailah lag berapa yang dah buat, katakan you buat sampai lag 5 lah contohnya. 1, 2, 3, 4, 5. Remember that lag 1 ya ialah correlation between YT and YT minus 1. Untuk lag 2, silap ya. So these are silap ya. So lag 1 here, lag 1 is a lag, katakan this is a point of lag 1. Then let's say this is a the maximum value here is equal to 1.0, cannot be greater than 1.0. The maximum point here is equal to 1.0. Let's say here is a lag 1. This is a lag 1. Let's say this bar is a bar chart. It's a bar chart here, bar here. This let's say here is lag 1. So lag 1, for lag 1, this is a correlation between YT and YT minus 1. Let's say this is a lag 2. Lag 2 here is the correlation between YT and YT minus 2. And let's say palang kat sini lah, katakan sini palang tinggi pula ni. This is a correlation between this part, this is the value here is a correlation between YT and YT minus 3. Let's say here is I have P here, let's say P here, and let's say ada banyak lagi, katakan sini P kat sini. This the value here is a correlation between YT and YT minus by P. Okay. The idea there. So you plot, in other words, you plot the data here is a correlation against lag. So the data here is a correlation, the correlation against lag. Depend on how many lags. You can this depend on you can use a maximum of 30 lag depending on how you want to interpret that. Okay, so depending on this one. So here is lag, the lag, or the lag here, and these are the coefficient corresponding to lag 1. Lag 1 means the correlation between YT and YT minus 1. Lag 2 is correlation between YT and YT minus 2, and so on and so forth. Okay. And then for PACF, the same thing apply to PACF. So for the PACF, the function here, the colligram here is a PAC, partial autocorrelation. The value here is also a maximum of 1 here, maximum of 1. Okay, the value here is this is the coefficient of AR1 model. Let's say this is a value for this 5.1 from linear regression. Is a AR1 model. AR1 5.1 of AR1. Let's say this lag 1, this lag 2. This is a 5.2 of AR2. Now let's say here is a 3, lag 3. This is let's say this the value here is this 5.3 of AR3 model, and let's say you have up to P here, like P. Let's say this is the value of P. This 5P, 5 sub P of ARP model. Okay. This is what I call the PAC function or PAC graph. Okay. Okay, setakat dia faham? Faham atau tak faham?
Doktor.
Faham, okey. So kalau faham, kita ambil break sekejap dalam masa 5 minit. Awak kena fikir balik kejap supaya tidaklah kata pening sangat. So kita ambil break 5 minit sekejap. Kejap lagi kita sambung balik. Boleh?
Boleh.
Okey, boleh So, kita break kejap Okey, kita sambung balik Boleh dengar Asma? Okey. Kita sambung balik. I share the screen here. Nampak screen Okay, nampak Okay. So basically we have PAC and ACF model, ACF graph or ACF plot. So macam mana how we want to determine which model to be used from this plot, these two plots. So basically the idea of plotting PACF and ACF is to determine which model to be used. Which model to be used, and for this case, so if our model here, our graph here is geometric, and PACF. So we have two model. We have two graph ACF. We have two plot ACF, and the other one is a PACF. Okay. So if we plot these two graph, let's say I plot here PACF. Let's say I have like this. Let's say I have I plot against the autocorrelation against 5 legs here. For example, I have 5 leg here. I have 5 leg. Let's say here AC autocorrelation, and then here I have 5 leg. Leg 1, leg 2, leg 3, leg 4, and leg 5. 1, 2, 3, 4, and 5. These are known as leg. Okay, leg. Now, if I find that the graph here is a geometry. Geometry means is a decay. From here you have top here, then it decays. Dia menurun secara exponential. It decay exponentially, geometrically. Decay geometrically. Dia menyusul gini. Decay ni maknanya dia berkurangan. So dia berkurangan ini dia exponentially or geometric. And then the other plot is a PACF plot. This is ACF. PACF plot. PACF. We have two plot here. Kita kena ada dua plot here. So here's a leg. So also 1, 2, 3, 4, and 5. Okay. There are the spike here. Let's say I have these are 50% point. This is a 45%, 0.45. Let's say this point is 0.45. The significant label here. So here is 0.45. The coefficient is 0.45. Let's say 45. Normally it's significant at 0. Now let's say I have a spike here. One spike here. Here is one spike. The rest is below this point. Or the thing here is below this point. Below this point. Okay. Maybe down there. Okay. So this is if you have a geometry, ACF is geometry, and PACF is we have P significant legs. P significant legs. So this is known as a AR1 model. AR1 model. Okay, AR1 model. Because of you have only one significant spike. Now let's say you have two significant spike here. You have two spike here. Two spike here. This thing become AR2 model. AR2 model. Okay, depending on the spike here. Okay? The spike. SPIKE. The spike. The spike. Depend on the spike here. So if you have two spike, if you have two, and then if you have three spike, is a AR3. Okay, so provided your ACF is a geometry. ACF is geometry. Okay, that is a AR model. Now, if you have like this, I have ACF here, ACF. If I have ACF, this, and then I have PACF, ACF and PACF. Now, if my PACF is a geometry, PACF is geometry, PACF is geometry. So I have like this, like this, like this, like this, like this, like this. Decay is decay against lag 1, lag 2, lag 3, lag 4, lag 5, lag 6. This is lag, for example. And then my ACF is spike. Let's say ACF is I have one spike here, one spike. The other is the rest is like this. This is 0.45, let's say, for example. And this is referred to, it's only one spike here, and PACF is a decay. This is known as a MA1 model. Okay. Now, if I have two spikes here, let's say here I have a spike here. The second leg is I have two spikes here. This referred to MA2 model. Provided PACF is a geometry or exponentially decay. Exponentially decay, or the geometry terms, in the term of geometry, the decay exponentially it goes to zero. From top it slowly goes to zero, gradually decay or gradually decay. So it is as a MA model. MA model depending on ACF. ACF is if you have one spike is a MA1, if you have two spikes is MA2, and so on and so forth. There is a how to detect MA model. These are for MA model. Now the last one, if I have ACF here, ACF function and PACF, both of them are decay exponentially. Decay exponentially. Let's say like this. Decay exponentially. And also PACF decay exponentially. This is also known as a ARMA model, ARMA model. Okay, ARMA model. So depending on ACF and PACF, these are how we use ACF and PACF to determine our model. Okay? Our model. Paham? Any response?
Faham.
Faham. Okay. So ini table ya untuk menentukan sama ada apa model yang digunakan. You can use this table. So in conclusion, I just write here for AR model. For AR model, you tengok dia punya decay, how it decays. For the AR model, AR model, you tengok. Kita concentrate about AR1. So AR1, your ACF is geometry. ACF is geometry. These are AR1. Okay. Then your PACF, this is ACF. Your PACF ada spike, satu spike here, for example, panjang. Then the rest is semua pendek. Okay. Okay, this is point here is 0.45, for example. So these are AR1. Okay. Decay and spike. Okay. Now for MA, spike, we have spike here. For ACF, ada spike, the rest is semuanya pendek-pendek je, ada satu spike. This is then your PACF is decay gradually, This is a PACF, and this is known as a MA model. Kalau dua-duanya decay, kita panggil ARMA model, ARMA model. ARMA is a combination of AR dengan MA, ARMA model. Itu secara kesimpulannya lah. So in conclusion, we can conclude that based on the table here. Okay. Now, kemudian kita pergi dari contoh-contoh di sini. Then we have also to find the model, so we can use there is one criteria here, one formula here. The formula here is known as AIC, ACF information criteria. So this also can be used to determine what type of model to be used. Okay, ACF information criteria, or AIC. Or maybe you can use, there is one more method, is ACF, this one, I think this one. So you can use, the other method is to use AIC method to determine the model. Okay, so dipanggil ACF information criteria. Okay. So for that, kita ambil satu contoh lah. Kita ambil contoh. Let's say I have an example here. I have pergi kepada website here. Go to website. Katakan saya pergi ke satu website here. Saya nak ambil data pada Twitter. Twitter stock price. Twitter stock price. I go to Twitter stock price. Okay. Saya nak tunjukkan macam mana saya tunjukkan spike. Okay, before that, before we go to this Twitter, kita ambil satu contoh lah macam mana you nak buat correlation ya. Okay. Now let's say I have the data here. Okay. Let's say I have the data here, my sales here. Let's say I have the data of sales. Nah, macam mana you nak buat correlation Kita tidak buat correlation lah Okay, I katakan saya ada data here. Let's say I have data of sales here. Sales time and sales here. Okay, Y is a sales here. YT. Okay. So hari pertama penjualannya lah katakan RM100 satu. Hari kedua RM200 dua. Hari ketiga RM300. Hari keempat RM400. Hari kelima RM500. Hari keenam RM600. Hari ketujuh RM700. Ada seminggu So ini jualan aiskrim pada for a period of 1 week. This is day 1, day 2, day 3, day 4, day 5, day 6, and day 7. So how you want to find the autocorrelation function? So I want to find autocorrelation of leg 1. Leg 1 is a correlation between YT and YT minus 1, isn't it? YT minus 1. YT and YT minus 1. This is a leg 1. So leg 1, kalau kita nak dapatkan leg 1, kita kena dapatkan YT minus 1, isn't it? YT minus 1 is, so we are comparing YT and YT minus 1. So our new YT, So kalau kita nak tengok YT minus 1, this is a YT. So YT and YT minus 1. So you have to write like this. Your new YT here is YT. YT here is YT. We compare today with the previous day. So we compare one with the previous day. Because of hari today, we do not have a data for the previous day. So we cannot compare this one with the previous day because of day 1 we do not have day 0 data. So this one you cannot compare. The only thing you can compare is 2 and 1. So your new YT is 2. Then YT minus 1 is, we are comparing today day 2 with day 1. So YT minus 1 is 1. So then the third day we compare with second day. Third day is 3. The second day is 2. Here is 4. Here is 3. Here is 5. Here is 4. Here is 6. Here is 5. And this part is 7. And this part is 6. So for this case, we have lost one data, isn't it? Because we are comparing today with the previous day. So day 2 we compare with day 1. Day 3 we compare with day 2. So this is your dependent, and this is your independent. Okay. So for the leg 1, we are calculating the correlation between YT and YT minus 1. So if you calculate the correlation between these two data, YT and YT minus 1, this will give you a ACF for leg 1. Okay, ACF for leg 1. Okay. So kalau you plot, you akan dapat satu leg 1, you akan dapat satu point here. Here is the coefficient you dapat tu. Contoh you dapat satu point here. Let's say if you calculate here, you can get, let's say you get 0.8. So satu point here, you get 0.8. You just draw a line here, 0.8. The maximum point here is 0.8. Okay. Now for leg 2, you are comparing YT and YT minus 2. So YT and YT minus 2. YT and YT minus 2. So leg 2, YT and YT minus 2. Now for this case, kalau kita nak compare YT here, so I have one here, I want to compare 2 steps before this. We do not have data here. YT here, let's say I assume that this is my YT. I want to compare this data with the previous one, two steps before that, 2 days before that. I do not have data 2 days before that. Now, if I compare these two with 2 days before that, I also do not have a data. So I can only compare 3 and 1 because I have data here 3 and 1. So my YT here is 3, the new YT is 3, and the new YT minus 1 minus 2 is 1. So then I have 4, I compare with 4 with 2, then 5, I pair 5 with 3, then 6 with 4, and the last one is 7 with 5. In other words, if you calculate the correlation between YT and YT minus 1, this is a leg 2 correlation. So you calculate, if you calculate the correlation here, the correlation here, so you get the leg 2 correlation here, the leg 2. So leg 2, we need to say for this case we are losing 2 data, right? Two data. So we are losing 2 data because we are comparing 2 steps ahead. We are comparing 3 and 1, 4 and 2, and so on and so forth. So we are losing 2 data. So the correlation between YT here and new YT minus 1, This is the autocorrelation for leg 2. So let's say, for example, if I calculate here, I get, let's say 0.7, for example. Let's say here is 0.7. So for leg 2, this is leg 1. For leg 2, I just plot 0.7 here, just right here. These are leg 2, this is leg 1, and so on and so forth. So you are comparing. So these are how you calculate the coefficient of correlation or the autocorrelation of depending on the leg. Depending on the leg. Kalau you ada banyak lagi, maknanya YT and YT minus 3 and so on and so forth. Depending. Last kali kita tak ada data lah. So kalau kita bandingkan YT dengan YT minus 3 dah, kita dah banding jauh lah. Maknanya we bandingkan 5 with 4 with 4 with 1, isn't it? 4 with 1, isn't it? 4 with 1, then 5 with 2, then you have 6 with 3, then 7 with 4. These are leg 3. Kita dah kehilangan how many data? 1, 2, 3 data. We are losing 3 data. So these are leg 3. Now if we calculate the correlation here, is a coefficient of leg 3 and so on and so forth. So these are how you calculate the correlation ataupun ACF ataupun autocorrelation depending on the leg. Faham tak? Respon? Faham? Hello?
Faham, Doktor.
Faham So maknanya, meaning to say, kalau leg 1 we are comparing today with previous day. Today ni maknanya kalau kita nak compare dengan semalam, maknanya hari kedua kita bandingkan dengan day 2 we bandingkan dengan day 1. Day 3 we bandingkan dengan day 2. Day 4 we bandingkan dengan day 3 and so on. That is ER1. Kalau ER2 kita bandingkan 2 hari sebelumnya. Hari ini dan 2 hari sebelumnya. Kalau hari ini hari keempat, kita bandingkan dengan hari yang kedua. Kalau ni hari ini hari kelima, kita bandingkan dengan hari yang ketiga. Hari ke-6 kita bandingkan dengan hari yang keempat. Itulah seterusnya. Then dia punya correlation between these two function, these two variable is known as a correlation, and this correlation is a autocorrelation. So you dapat data ni, you plot lah. You plot. Maknanya prosesnya panjang lah. So kalau you ada 10 leg, maknanya you kena kira 10 kali lah correlation. So there is a correlation. This is how we calculate the correlation. Now the next part is I want to show you how to calculate the PACF. PACF we apply the same method also. PACF. Now katakan kita ada data just now YT. Okay, kita ada YT kita ada YT here. YT. So I have 1, 2, 3, 4, 5, 6 and 7. Okay, now kalau saya nak buat kemudian saya ada YT minus 1 is so saya ada kemudian saya ada Y 2, 3, 4, 5, 6, 7. Kemudian kita ada 3, 4, 5, 6 dan 7. Dan kemudian saya ada 4, 5, 6 and 7. Then I have 5, 6 and 7. The rest is not significant, agak kecil sangat. So kalau ini is YT, This is yt. Here is your yt. Okay. Silap, eh. Kalau this part is your yt, kalau if this one is your yt, this one is your yt, this is yt minus 1, isn't it? You compare 2 and 1, 3 and 2, 4 and 3, 5 and 6, 6 and 5, 7 and 6. If this is your yt, this is your yt minus 1. Now, if this is your yt, this is your yt minus 2. This is yt minus 2. This is yt minus, this is yt minus 2. Yt minus 2. Dia buat gini lah, ini confused, eh. So, let's say I have data list yt 1, 2, 3, 4, 5, 6, 7. So, I want to compare yt and yt minus 1. So, my yt is yt become 2, 3, 4, 5, 6, dan 7. Yt minus 1 is 1, 2, 3, 4, 5, and 6. Kalau you regress yt against yt minus 1, you will get, you dapatkan kali korelasinya. Kalau if you regress yt with yt minus 1, so you have yt here equal to 5, 0, 5, 1, yt minus 1 plus by epsilon t. And this 5, 1 here is your PACF or PAC, partial autocorrelation. This one, 5, 1. Kalau you regress yt with yt. Assuming that this is your y and here is your x. Okay, independent and dependent. Now, if you regress, katakan kita ada lagi banyak variable here. Let's say I have yt here. I nak comparekan dengan 2 step. So, I want to compare with yt minus 2. So, I have here, I want to compare with yt minus 2. So, yt minus 2 here is what? So, I have, if my data here is 3, yt minus 2 is 1, 4, yt minus 2 is 2, here is 5, yt minus 2 is 3, 6 is 4, and 7 is 5. Then yt minus 1 is 1, 2, yt minus 1 is yt and yt minus 1 is here is, kalau 3 kita bandingkan dengan yt minus 1 is yt minus 1. So your yt minus 1 is 2, 3, 4, 5, and 6. Now, if you calculate the regression here, you calculate the multiple regression here, this thing become yt equal to 5 naught plus by 5, 1, yt minus 1 plus by 5, 2, yt minus 2 plus by epsilon t. So this 5, 2 here, 5, 2 is there, this PAC for leg 2. So you just pick up 5, 2. You don't bother about 5, 1 because of this is partial. So 5, 2 here, for this multiple regression, this 5.2 is your PACF leg 2. And 5.1 here is PACF leg 1. So don't confuse. So if you want to find 5.1, you have to regress YT and YT minus 1. If you want to find 5.2, you have to regress YT against YT minus 1 and YT minus 2. So before that, you need to have a data here, YT and YT minus 1 and YT minus 2. So you pick up only 5.2, and this 5.2 is a PACF for leg 2. This thing apply to leg 3 and so on and so forth. So you have to get data here first. This is your dependent variable. In case of multiple regression, this is a dependent variable. And these two is your independent variable, independent 1 and independent 2. If you have 3, you want to go for the leg 3, you have to get uh, four groups of data, YT minus 1, YT minus 2, and YT minus 3. You find the multiple regression, and 5.3 is your PACF for leg 3. That's how we calculate the autocorrelation function, PACF function. Boleh? Dia kerjanya panjang sikit lah. So setiap kali you need to find the regression, multiple regression, multiple regression, multiple regression, multiple regression, and multiple regression. So you need to find so many multiple regression. So this work is quite tedious. So that's why we need to use a package or software to solve this problem. Okay. Now, let's say faham tak konsep ni? Any respond? Hello?
Boleh doktor.
Boleh So dengan kata lain, kalau you nak cari PACF, you have to run so many regression. First is a linear regression. YT and YT minus 1 is known as a linear regression. Kemudian YT against YT minus 1 and YT minus 2 is a multiple regression lah. Then YT, the third leg is YT against YT minus 1, YT minus 2, and YT minus 3. That is a leg 3. It's also multiple regression. But the only thing is that the only thing you want to pick up is 5.1, kemudian 5.2, 5.3, and 5.4, 5.5, and so on and so forth. Even though you have multiple regression, you just pick up one single variable, depending on what level of regression. If you have 5 level, you pick up only 5. If you have 3, you run a multiple regression for 3 variable, you pick up only 5.3, and so on and so forth. And that value is referred to PACF. So to do it manually is quite tedious. A regression, a correlation, okay, correlation you can do it. It's quite easy correlation because we just have a 2 variable here. For the multiple regression, for the single linear regression is quite okay, but when come to multiple regression is quite tedious. The calculation is quite tedious, so that's why we use software to solve this problem. So I want to show you how to use the software SPSS to solve this problem. So we go to data here. I have a data here. The data here is a stock price for Twitter. This is a Twitter stock price. I go to historical data. Okay. I go to historical data. Okay. Now you can choose here. You can pick up any data here. You can just assign daily, monthly, yearly data. So let's say I pick up a daily data from November 1 year daily data. So that's approximately I have 240 data because of we do not calculate the holidays. So we have Sunday and Monday. Sunday and Saturday and Sunday. Saturday and Sunday there is no stock exchange. The market is closed. It's on Saturday and Sunday. So normally it's for 1 year starting from November 27 November to 27 November this year. So you have around 200, approximately around 200 data. So I just download here 200 data. Okay. So I have 200 data here, or less than that, maybe less than that. Okay, so I have data here. Okay, kalau kita tengok di sini, I have okay, more than 200. Okay, I have 253 data. Okay, so I just pick up, let's say for example, I just pick up here the closing price. There is an opening price, high price, low price, and closing price. You can use either one. This is just for the exercise. It's a Twitter price. 31.17 means 31.17 US dollar per unit. The price for Twitter is $31, 31.17, which means it's around 150 ringgit per unit. Per unit. So just pick up this one. I just pick up this one, this data. Pick up this data. Okay. I copy this one. Copy is Control C. And then I go to my SPSS. So you can download SPS. It's a student version. Okay. You can download SPS student version. Okay, this is my SPS. Now, let's say I pick up all the data here. Okay, I pick up all the data here. I select all, but then I can delete the data here. Okay, so I select all. Okay, wait. So ini, tapi kan kita ambil semua data ni. Kita ambil date. We take date up to closing here. So kita ambil semua ni. Kita boleh delete lah. Kita boleh delete lah. Tanda kita boleh delete. So just pick up here, this one, Control C. So Control C is just a copy here, and then I paste here. So Control V, I paste here, ataupun you can put. So this is your date here. Date. This is the opening price. So I put there. I just give a variable name here. Just create a variable name. I just put here is a date. Date is opening price, opened, high, and low price, low, high for that day, then close. Okay, so there are three. So what I interested here is in the close price. Oh, say this is a low, high, low. Okay. This is a high, this is a low, this is a high, this is a low and low. Okay. Low and high and low. This high and this is a low price. Okay. This is a closing price. So what I'm interested in the closing price. Let's say. Now before that, maybe you can play here. You can draw a graph here. Let's say. So to draw a graph here, you go to analyze. Okay. You go to analyze. You go to forecasting here. Forecasting. Then you go to sequence chart. So you go to sequence chart. You go to sequence chart. Let's say I want to find the graph for closing price. Close variable. The time is date here. So I can cut it here. So I just put the OK here. So it will give me a graph here for 1 year price here. So by looking at this one, we can say that the data is not stationary because there is a cycle here, isn't it? There is a cycle here, and this is also a cycle. Even though, and then your trend is not the trend is not consistent. It's not constant. So the trend is not constant. If you draw a line here, even though if you draw a line here, the trend is not constant. So this is what I call the non-stationary data. So, but it's okay. But if you want to perform a stationary data, you want to use this data. Still, you want to use this data. You can use a different thing, isn't it? We have learned differencing and transformation to transform this data into stationary and to do a differencing to get a stationary data. That's later on. So if you transform, if you use analyze here, you can transform the data into a stationary data. So I go to forecast, I go to sequence chart, I just do a differencing. Difference by, let's say difference by 2. Difference by 2, just draw here. So if I difference by 2, so or I just analyze a difference by, I go to difference by 1. So sequence chart, I difference by 1. That's difference by 1. Then I go to difference by 1. Then the chart is a bit, you can see that the data here is become stationary, except for this one, the little bit of this one. So the thing here, the mean here is constant, and then you can see that your what you call the variance is a bit constant, a little bit here, it's a bit spike here, but we can assume that this is data is a stationary data. Okay? So assume that the data is stationary. Okay? So because of that is a process to stationarize the data. So assume that this data is stationary. So I want to find the PACF and PACF and ACF graph. Eh? So I want to plot here. So to plot ACF and PACF graph, you can go to analyze here. You can go to analyze. You can go to forecasting here. Then you can go to auto correlations. Auto correlations. And then you can pick up the price here, open price. Or let's say the close price, closing price, the closing price. Then you can go to options here. Then you can pick up a maximum number of legs. Normally we do not go for so many legs. We just put, let's say by default is 16. So we just put, let's say that I put 10 legs. 10 legs. 10 legs. 10 legs. I want to, or just put 16 by default. Okay, 16 legs. Okay. So then I just click continue, and then I click OK. So give me this leg value and the thing here. Okay. So you cannot see the decay. Okay. Never mind. We go to analyze again. We go to analyze forecasting, and we go to auto correction as example. I go to more legs here. I go to, let's say I go to 30 legs. 30 legs. So then I can see the difference here, the T-leg. So you can see here, the price here, the ACF is a decay from top here, it goes down here and go down here and go down here. It's a gradual decay, a slowly decay. It's a geometric function, geometric function. And then for the PACF, this is a PACF value. The PACF, there is a one spike here. One spike here. There is one spike. So one spike. So by definition, if we have a decay ACF and a spike in PACF, we refer to what model? Any response?
AR1.
AR1 model. Okay, AR1 model. So one spike. So you can see here, this is the borderline. This is a significant line here. This is a significant line. This is a significant line. Even though there is a significant one part here, one bar here, but the spike here is this is a very extreme spike. So you have one spike here, and then it decays, it geometrically decay or exponentially decay, and this is referred to your ACF is decay function, and this is you have a spike here, one spike here. This is referred to AR1 model. And so this is how we determine the model. This is a AR1 model. So in other words, you can regress, you can get the data, you can regress YT, the open price. YT is open price, closing price equal to 5 naught plus by 5 1 also a closing price YT minus 1. Closing price. So the closing price plus by X dot T. So meaning to say, if I want to plot, I want to get the AR model here to get the coefficient or the coefficient here, okay, to estimate the model here. So I can plot YT against YT minus 1 because of this AR1 model, okay. So how to plot AR1 model, YT and YT minus 1? So we go back to the data here. So because of AR1 model, we can write like this. So we go to our data here. So we go to the data here. Okay, kita pergi ke data balik. Now, we focus on closing price. This is a today price. So for AR1, we have close. Let's say here is YT. We need to have YT minus 1. So meaning to say YT is we are comparing today and the previous day. So we are comparing 3091 with 31.17 today with the previous day. Okay, today is 30, we are comparing with 31.47. 30.42 we are comparing with 30.49. So close, this is a close, then we have close minus 1. So this is a, we are comparing this one. We are comparing okay. So meaning to say, this one is meaning we are comparing this data with previous one. We are comparing here. We are put here. Yeah, put there. Okay. Meaning to say I compare 30.91 and 31.7. This is a YT and this is a YT minus 1. I compare 30.42 with 30.91. 30.42, 30.91. Okay. So this is a YT, this is a YT minus 1. So I change here. Let's say I put here is a YT. Closing is YT. And this is a YT. YT. Y small t. This is a YT. YT. Y. Y small t minus 1. This minus. You cannot give a variable name minus. You can say here is y y yt 1, yt minus 1. Yt1 means yt minus 1. Okay, so I have data here yt and 1. So then I can run a regression here. So just delete here. So I go down here. I just delete extra data here. So I just delete this one because of we are losing one data. Okay, we are losing. So I can get the regression line here. So I can get the regression yt my dependent yt minus 1. So I analyze here. Analyze. I go to regression. Go to regression, linear regression. Okay. Go to linear regression. Regression. Go to linear one, linear regression. So my dependent variable is yt, and then my independent is here is yt minus 1. Yt minus 1. So statistics, I just estimate R square change, model fit, all these things. Just continue here. Just click OK here. Then we'll get the coefficient. So meaning to say this coefficient here, your function here become this unstandardized value. So your yt here, the function here, the AR1 model here become AR1 model is your yt, the closing price yt is equal to this closing price is equal to the constant is 0.744. It's a 50. It's a 50 plus by your phi 1 is 0.981 yt minus 1 plus by x log t, or you just put like that. You don't have to put the echelon here. You do have. So these are the model here. You have the model here. These are your model. Okay. Y hat is a 5-1. Okay. So this is your 5-1. The 5-0. This is your 5-0. This is a 5-0. 5-5-0. And here is your 5-1. Okay. 0 and 5-1. Okay. 5-0 and 5-1. No. So this is how we write the model here. Okay. Now, in terms of words here, you can see here is a low price, closing price, closing. You can write here is a closing price. Closing price is equal to 0.744, the constant, plus by 0.981, closing price minus 1. Closing price before that. This is your the ER1 function. Okay. So I think that's all for today. Now it's 11 o'clock already. So that's all for today. So untuk makluman so minggu depan kita akan adakan satu ujian. Ujian kita ialah berkenaan dengan apa yang telah saya ajari semenjak daripada awal hinggalah hari inilah sampai AR1. Macam mana nak mengenal pasti AR1, MA1, AR model. So ujian kita berkisar kepada soalan-soalan yang itulah apa yang saya berikan. So for the exercise today, you can go to, let's say, you go to the website just now. You boleh tengok, you go to, you main-main kan, you pergi ke, let's say for example, you go to price for Zoom. There is a share on Zoom, Zoom. Share price for Zoom. You ambil share price for Zoom for 1 year, daily price for 1 year. You cuba plotkan dia punya PACF and PACF. Tengok dapat tak? And before that, let's say I have data here. So this is question number 1. Question number 1, okay, exercise, you don't have to send to me. So question number 1, you go to Zoom, data Zoom. Zoom ni bukan, Zoom ni is a Zoom yang we use the software Zoom, so for video conferencing. But Zoom also, there is a share on Zoom, share on Zoom, share price on Zoom. You go to Zoom data for 1 year, 1 year data, 1 year. You plot ACF and PACF. This is question number 2. Exercise number 1 is, I have data here, Y, let's say Y, my YT. This is, let's say, sales, for example. Sales. Then I want you to plot, I want to, let's say, my sales here is 20, 30, 40, 30, 35, 60, 70, 70, 70. Then I have 85, 90, and 100. This data. So I want you to find. I want you to plot ACF function, or plot ACF plot for leg 1, leg 2, and leg 3. And also I want you to plot PACF for leg 1 and leg 2. This you can use a software. You can use a software. Leg 1 and leg 3. This you can use a software. You can use software. And this I want you to calculate manually. This you calculate manually. PACF you calculate manually, and then the ACF you calculate manually. PACF you calculate manually, and determine what type of model here. What type of model? What model to be used? What model to be used? Here also you need to determine what model to be used. Okay. Okay. Ada dua latihan ni. Cubalah tak yang tadi ya. Just cuba untuk memahami dah konsep ACF and PACF. Okay. Boleh Respon? Okay. Okey, saya rasa itu sajalah untuk pagi ni. Dan ingatlah pada minggu depan pada 5 hari bulan 5 hari bulan hari Sabtu on the 5th of December 2020 kita akan adakan ujian test bermula jam 9 pagi lah. Saya akan uploadkan pada pukul 9 pagi dan kita akan berakhir pada pukul 6 petang ataupun 6 petang lah. So maknanya awak ada ujian separuh hari lah, 9 pagi hingga 6 petang. So ada a few question you can read yourself, then you can email to me lah. You can email to me. Sorry, you send to the platform. So I provide a platform. Provide a platform. You send to the platform. Okay. Ataupun worst come to worst, if you cannot send the platform, if they have a problem is the internet connection, you can email to me lah. So I prefer you to send to the platform the answer for the test. So ingat so please inform other people, other friends. Your test is on the 5th of December 9 pagi hingga 6 petang. Cuba lapangkan diri. Kalau ada kumpul kahwin tu bolehlah pergi kejap pergi lari kejap dan datang balik So 9 pagi saya bagi soalan tu you selesaikan dalam masa 8 jam. It's quite long lah. Normally our test is 1 hour because of case of COVID here. I gave you 8 hours to do a test and you have ample time to submit the result. Jangan submit the result last minute, takut the line cramp ataupun congested so you after you finish you can submit earlier lah. So make sure that you have submitted your answer. So test is on 5th of December. Repeat a test on 5th of December 2020. Okay, that's all for today. Thank you very much. Ada soalan satu soalan, dua soalan?
Doktor, yang soalan latihan tu kena hantar ke?
Tak payah hantar, untuk latihan saja. Sebagai latihan awak lah, untuk pengukuhan.
Okey.
Okay, yang lain? Tak ada So, thank you very much. That's all for today. So, yang tidak dapat mendengar rancangan saya ni, anda boleh upload, anda boleh tengok video video pada pada masa-masa yang lain. Okay? Anda boleh tengok video pada masa lain. Saya rasa itu saja. Assalamualaikum. Saya akan upload video tu bukannya hari ni tak sempat. Mungkin besok lusa awak akan dapat video tu. Dan so you boleh tengok video lah kalau yang tidak dapat hadir pada pagi ni. Sekian. Assalamualaikum warahmatullahi wabarakatuh.
Terima kasih doktor.
Thank you, doktor.
Terima kasih doktor.